Hi guys, welcome to 3.3, which is sine and cosine function values. This is really going to be an extension of what we talked about in 3.2 using our unit circle, but also just knowing those relationships between sine, cosine, and tangent. All right, so now everything's not going to necessarily have a radius of 1, okay? So now we're going to have a different length of the hypotenuse or radius, however you want to kind of think about it. And so we want to be able to find all different values. So I see the terminal side contains the point -5, 3. Find the exact values of sine and cosine functions of theta. Use radicals if necessary, but no decimals. So it gives me this point. Best thing to do is to kind of draw a triangle. I see x is -5. That should make sense because I've gone to the left. That's negative. And 3. But notice I'm not given the hypotenuse, so we need to reach all the way back into our math 1 and 2 brain and say, hey, if I have two sides of a right triangle, I want to use Pythagorean theorem to find the third. So I have -5 squared plus 3 squared equals r squared. That would be 25 plus 9 is r squared. So r would be the square root of 34. Again, because I have to get r by itself. All right, so then I want sine and cosine. So sine of theta is opposite over hypotenuse. So that is 3 over square root of 34. It doesn't tell me right here that I need to rationalize, so I'm just going to leave it like that. Let's just talk about, though, if I did need to rationalize this, what I would do is I would multiply by the square root of 34 on the top and the bottom, and that would get me 3 square root of 34 over 34, and that would be rationalized. It doesn't tell me that in this case, so I'm not going to do that on each one. And then cosine would be -5 over square root of 34. Okay, so just kind of knowing adjacent over hypotenuse, opposite over hypotenuse. All right, next one says, let theta be an acute angle. That means it's between 0 and 90, which means it's in quadrant 1. And sine of theta is 5, 6. So I'm just going to kind of draw this out. Sine, remember, is opposite over hypotenuse. So if I draw my angle theta there, opposite is 5, and then 6 is my hypotenuse. I'm drawing in a right triangle, but I'm missing the third side, so I'm going to use Pythagorean theorem to get there. So I get x squared plus 25 equals 36. Subtract that over, I get x squared equals 11, so x is the square root of 11. So if I was going to find cosine of theta, that is adjacent, which is square root of 11 over hypotenuse, 6. And then tangent of theta is opposite over adjacent. Opposite is 5 over adjacent is square root of 11. It doesn't tell me to rationalize, so I'm just going to keep that. Okay. All right. Example number 3 says it's in quadrant 3 and tangent is 4/7. Okay. Remember that's opposite over adjacent. So opposite is 4 and adjacent is 7. However, we want to be really careful here. Okay. I'm in quadrant 3. So really these are both negative here. Okay. And it ends up positive because I have a negative divided by a negative. All right. So I need to go ahead and find my hypotenuse. (49 plus 16 is 65, hopefully. So that would end up being the square root of 65. And I want, let's see, I want sine and cosine. So sine here is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay. All right, so we're going to skip the next page because that's really just doing a bunch of unit circle that we did before, okay? And we're going to go on and do a little bit more practice with this on example number 5. All right, this piece right here is very, 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 very important. And the reason I say it's very important is it's not just important for what we're doing in this unit, but it's going to take us through to something called polar and also something called vectors, okay? So if you're going to pay attention to anything, pay attention to this. So if I see here, I know that I have x and y and r. So essentially, we've said this before, sine is y over r. Well, if I wanted to solve for y here, y would essentially be r times sine of theta. If let's say I multiplied both sides by r. Same thing here. Cosine of theta is x over r, so x equals r cosine theta. And tangent is y over x, and we don't really have a fancy way of saying that. That's just the slope of the line, okay? Again, this will come back up with polar and vectors, so make sure you understand these two things will just have to be kind of off the top of your head. Y equals r sine theta, x is r cosine theta. So let's go ahead and look at coordinates of a point. And again, this is another one that will come back up when we do polar, which is the second half of this unit. Given a measure of standard angle of 4 pi over 3 with a radius of 5, we want to find the point xy. Well, x is going to be r, which is 5, cosine theta, which is 4 pi over 3. Y is r sine 4 pi over 3. All right. Now, I have to know what the sine and cosine of 4 pi over 3 are. This coordinate would be negative 1/2, negative square root 3 over 2. That's where my unit circle comes in handy. So I get negative 5/2, and then negative 5 root 3 over 2. Again, knowing x is r cosine theta, y is r sine theta, you can always derive those by just knowing sine is y over r, cosine is x over r. Okay? All right, 2 more. We're going to look at examples 8 and 9. Now, 8, it just says find all values of theta between 0 and 2 pi where cosine is 0. Cosine is my x value, so we're thinking, where have I not moved left and right at all? Well, that would be at the top and at the bottom of my circle. That is therefore pi over 2 and 3 pi over 2. And that's it. And lastly, number 9, it says tangent of theta is 4/3. Well, let's think about where could this be. Tangent is positive in quadrant 1 and in quadrant 3, because I have a positive divided by positive or a negative divided by negative. And cosine of theta is negative. So we think, where is cosine negative? Well, that could happen anywhere that's on the left side. So quadrants 2 or 3. Where do both of those things happen is in quadrant 3. So that's where this problem is going to take place. Okay, so remember, this is opposite over adjacent. Opposite is 4, adjacent is 3. But we say to ourselves, wait a second, that doesn't seem exactly right. Those both need to be negative because I'm in quadrant 3. The reason that I ended up with a positive is because I divided 2 negatives. So to find r, I use Pythagorean theorem. And this is actually a Pythagorean triple. You may recognize it. It's a 3, 4, 5 triangle. When you do the math, the radius ends up being 5. All right, so then sine of theta, here's my theta right here, is opposite over hypotenuse, negative 4 over 5. And then cosine of theta is adjacent over hypotenuse, which is negative 3 over 5. Okay, so hopefully that gives you a better sense of kind of what's happening, extending it, not just when my radius is 1, but if I have a different radius. Remember, x is equal to r cosine theta and y is equal to r sine theta. Hope you have a great rest of your day.